Ever wondered about the future of ship propulsion and the role of hydrogen in it? As we sail into the future, we're increasingly seeking alternative, more sustainable forms of energy to drive our ships across the globe. The maritime industry is undergoing a significant shift, moving away from traditional fossil fuels and towards cleaner energy sources. Among these emerging alternatives, hydrogen stands out as a potentially game-changing solution. Hydrogen propulsion for ships involves the use of fuel cells. These ingenious devices convert hydrogen into electrical energy, which then powers electric motors. The result? A ship that glides through the water, propelled by the most abundant element in the universe: hydrogen. But why hydrogen, you might ask? Well, when we talk about sustainability and clean energy, hydrogen checks all the boxes. It can be produced through various methods, including electrolysis, which uses electricity to split water into hydrogen and oxygen. And if we use renewable energy sources for this process, we get green hydrogen, an environmentally friendly and sustainable energy source. Once produced, hydrogen is stored on board the ship in high-pressure tanks or as a cryogenic liquid, depending on the storage technology used. Distribution systems then ensure that this hydrogen is delivered to the fuel cells when needed. The heart of the hydrogen propulsion system is the fuel cell. It's here that the magic happens. Hydrogen and oxygen are converted into electricity through an electrochemical reaction. The produced electricity is then used to power the ship's electric motors for propulsion. The electric power generated by the fuel cells is used to drive electric motors connected to propellers or other propulsion systems. These electric motors convert the electrical energy into mechanical energy, providing the thrust needed to propel the ship. And the best part? The only emission from the hydrogen fuel cell system is water vapor. This makes it a clean and environmentally friendly propulsion technology. Now that we have set the stage, how exactly does hydrogen propulsion work? Stay tuned as we delve deeper into the fascinating world of hydrogen propulsion in the following scenes. Firstly, we need to talk about hydrogen production. The hydrogen used for ship propulsion can be generated in a few ways, but the most common methods are electrolysis and reforming natural gas. In electrolysis, an electrical current is used to split water into its basic elements, hydrogen and oxygen. On the other hand, natural gas reforming involves a process where methane from natural gas reacts with steam under high pressure and temperature to produce hydrogen. Now let's talk about green hydrogen. This is a type of hydrogen produced using renewable energy sources, which makes it an environmentally friendly and sustainable option. It's a win-win, because we're not only harnessing the power of renewable energy but also creating a fuel that, when used, only emits water vapor. Once produced, the hydrogen needs to be stored and distributed, but we'll dive into that in the next part of our journey. Storage and distribution of hydrogen play a crucial role in its use as a fuel. On board a ship, hydrogen can be stowed away in two different forms, depending on the storage technology employed. It could either be stored under high pressure in specially designed tanks or as a cryogenic liquid, cooled down to extremely low temperatures. The method of storage is chosen based on factors such as space availability, the ship's energy requirements, and safety considerations. Once stored, the next step is getting this hydrogen to the fuel cells when it's needed. That's where distribution systems come into play. These systems are like the ship's veins, ensuring a continuous flow of hydrogen from the storage to the fuel cells. They are meticulously designed and monitored to maintain the right pressure, temperature, and flow rates. With these systems in place, the ship has a steady supply of hydrogen, ready to be converted into power. Now that we have our hydrogen ready and distributed, let's move on to the heart of the propulsion system, the fuel cells. Fuel cells are the magic behind hydrogen propulsion. So, let's pull back the curtain and reveal how they work. They're essentially the heart of the hydrogen propulsion system, acting as the conduit that transforms hydrogen and oxygen into electricity. This transformation is not some mystical process, but a well-understood electrochemical reaction. Fuel cells are like mini chemical plants, constantly churning out electricity as they perform their function. But how does this process work? Quite simple, really. Hydrogen, our primary actor, enters the fuel cell and is split into electrons and protons. The protons pass through a membrane, while the electrons create a current that can be utilized for electricity. Meanwhile, oxygen plays a supporting role. It enters the fuel cell and combines with the electrons and protons to produce water. This is the basic reaction in a hydrogen fuel cell, expressed in a scientific equation as 2H2 plus O2 yielding 2H2O plus electricity. It's fascinating, isn't it? This little dance performed by hydrogen and oxygen, under the watchful eye of the fuel cell, generates electricity. This isn't any ordinary electricity, but a clean, efficient, and sustainable form of energy that can power massive ships across the vast oceans. But let's not get ahead of ourselves. It's important to remember that the electricity produced by these fuel cells isn't used to light up the ship's deck or power the captain's radio. No, it has a much more critical role. The electricity produced by these fuel cells is then used to power the ship's electric motors. That's right. The main purpose of this electricity is to provide the juice for the electric motors. These motors, in turn, convert the electrical energy into mechanical energy, thereby providing the thrust that propels the ship forward. So next time you find yourself marveling at a ship gliding smoothly across the water, remember the fuel cells. These little powerhouses are the unsung heroes, quietly working away in the background, converting hydrogen and oxygen into the electricity that powers those majestic vessels. The electric power generated by the fuel cells is put to work in the electric motors. Let's dive into how this happens. The electric motors, you see, are the real workhorses of a hydrogen propulsion system. These motors take the electricity produced by the fuel cells and convert it into mechanical energy. This energy is used to drive the ship's propellers or other propulsion mechanisms, thus providing the thrust needed to propel the ship through the water. Just imagine, the energy that started as hydrogen and oxygen, transformed into electricity, is now being converted into the force that pushes a massive ship forward. It's a beautiful symphony of science and engineering, a testament to human ingenuity. Now, let's talk about the emissions. Traditional combustion engines burn fossil fuels and release harmful gases, such as carbon dioxide, into the atmosphere. But with hydrogen propulsion, the story is quite different. The wonderful thing about a hydrogen propulsion system is its emission, or rather, the lack thereof. You see, the only byproduct of the electrochemical reaction in the fuel cells is water vapor. Yes, the same harmless water vapor that you see when you boil a kettle. This water vapor is released into the atmosphere, effectively making a hydrogen propulsion system a zero-emission technology when green hydrogen is used. It's a breath of fresh air, isn't it? In an age where we're fighting to reduce the carbon footprint, this technology offers a glimmer of hope. It's a significant stride towards clean and sustainable maritime transportation, a step towards a future where our oceans are traversed by ships that do not contribute to air pollution. So, we have a system that produces only water vapor as a byproduct. Sounds perfect, doesn't it? While hydrogen propulsion offers numerous benefits, it also comes with its own set of challenges. Let's delve into these aspects to get a comprehensive picture. First, the benefits. The most noteworthy advantage of hydrogen propulsion is its zero-emission nature. When powered by green hydrogen, the only byproduct is water vapor, making it an environmentally friendly propulsion technology. Imagine a world where our oceans are traversed by ships that leave no carbon footprint. That's the promise of hydrogen propulsion. Next up, efficiency. Hydrogen fuel cells pack a potent punch in terms of energy density, offering a clean power source for ships. This efficiency can translate to longer ranges and reduced fuel costs over time. And let's not forget the reduced noise and vibration. Electric propulsion systems, including those powered by hydrogen fuel cells, often operate much quieter compared to traditional combustion engines. This can lead to a smoother and more comfortable journey for passengers and crew alike. But like all technologies, hydrogen propulsion comes with its own set of hurdles. Developing a robust hydrogen production and distribution infrastructure is a significant challenge. It's not just about producing hydrogen, it's also about getting it safely and efficiently to where it's needed. Storage and handling of hydrogen on ships is another crucial consideration. Given hydrogen's low density and high flammability, safe and efficient storage solutions are paramount. Lastly, there's the cost factor. The initial investment for hydrogen fuel cells and associated technologies can be substantial. However, ongoing advancements are expected to bring these costs down, making hydrogen propulsion more financially viable. As we wrap up, let's peer into the future. The maritime industry's shift towards cleaner and more sustainable energy options aligns perfectly with the potential of hydrogen propulsion. Continued research and development aim to address the technical challenges and make hydrogen propulsion a widely adopted solution for ships. As we continue to innovate and find solutions to these challenges, the future of shipping may very well be powered by hydrogen.